Beneath the eternal silence of space, there is a rhythm, not of sound, but of motion. An invisible choreography that binds every grain of dust, every moon, every star. Gravity, the quiet sculptor of creation. It pulls the oceans toward the moon, holds mountains to the crust, bends the very light that dares to flee a star. It is the universe's oldest promise that everything which drifts will one day fall, from the faintest speck of cosmic ash to the heaviest black hole. All things obey this ancient current. Nothing escapes it. Nothing resists until now. In the cold stillness between planets, something moves differently. A pale spark in the darkness, smaller than a mountain, faster than anything bound to the sun. Telescopes catch it first as a flicker, a shifting pinprick among the stars. An interstellar traveler, catalogued under a sterile name. 3I, a third known visitor from beyond the solar system, wandering through our celestial neighborhood like a ghost uninvited. At first, astronomers think it's a comet. It behaves like one, almost, but the data betrays the illusion. Its speed does not change, not even as it glides near Earth's gravitational field, where the pull of our planet should bend its path ever so slightly. It does not curve. It does not fall. It continues on, unbothered, unbowed, as though the planet's mass, oceans, and atmosphere were no more significant than a mote of dust. Across observatories, calculations are checked and rechecked. Software models run through the night, tracing orbital lines that refuse to fit. Every known law insists that gravity must act, that no body can pass through the solar system untouched. And yet, this one does. In the deep rooms of data centers, scientists whisper in disbelief. Could there be an error, a trick of light, a miscalibration, a cosmic coincidence? Or has the universe just shown us that its oldest law has limits? Through the glass eyes of telescopes, the object drifts onward, serene, indifferent, carrying secrets from stars we have never seen. It neither accelerates nor slows, obeying some hidden rhythm beyond the reach of our equations. And as it fades into the void, one question begins to echo louder than the rest. What happens when the one law that holds the cosmos together simply stops working? It began, as such discoveries often do, not with revelation, but with a flicker, a ghostly dot of light caught by the Pan-STARRS Observatory on the slopes of Haleakalp in Hawaii. A single point moving ever so slightly against the background of fixed stars. At first glance, it was nothing unusual. The sky is full of wanderers. Fragments of rock and ice tracing their ancient paths around the sun. But this one was moving too quickly, gliding across the firmament at a speed that defied the gravitational signature of the solar system itself. When the data was processed, the algorithms hesitated. The trajectory didn't close. Its orbit wasn't elliptical, or even parabolic, it was hyperbolic. This meant only one thing. The object did not belong here. It came from somewhere beyond the sun's dominion, from the dark interstellar sea that separates the stars. Astronomers gave it a name, a simple, sterile sequence of characters, -3 IATLAS, the third interstellar object ever recorded. But behind the label, something extraordinary had entered human awareness. The first, 1I Aumuar, had passed years before. Long, thin, tumbling strangely, accelerating as if pushed by unseen hands. Then came to I Borisov, more comet-like, its icy tail a familiar sight, a traveler that still obeyed the sun's warmth. But 3I Atlas was different. It carried no tail, no reflection of volatile ice. It emitted no spectral signature of water or carbon compounds. And most troubling of all, it did not slow down as it moved closer to the inner solar system. It passed through the region where gravity should have seized it, where the invisible pull of the sun and earth should have subtly altered its course. Yet the curve remained straight, the path unbent. The object seemed to ignore the weight of the worlds around it, as though space itself were allowing it passage unimpeded. At NASA's Jet Propulsion Laboratory, orbital analysts ran simulations deep into the night. The equations faltered, refusing to reconcile velocity with mass. Newton's clean geometry of attraction, the harmony of motion that ruled the heavens, began to tremble under the precision of modern measurement. Every known model demanded deceleration under solar influence, but 3I Atlas moved as if gliding through emptiness, untouched by pull or drag. Data streamed in from the European Space Agency's Gaia mission, from the Hubble Space Telescope, from small amateur observatories watching from mountaintops around the world. The international scientific community turned its collective gaze toward a single wandering light. No instrument found evidence of jets, no vapor, no faint whisper of outgassing that might act as a hidden engine. Its surface, when examined through spectrometry, appeared inert, dark, metallic perhaps, or something unknown entirely. The mathematics grew desperate. To preserve the sacred order of celestial mechanics, some proposed introducing a corrective term, a hidden parameter, a tiny adjustment to the gravitational constant that could make the numbers fit. But such an act bordered on heresy. To alter gravity was to alter the structure of everything. And so, night after night, data was recalculated, telescopes refocused. And yet the truth remained the same. 3I Atlas moved where gravity said it could not. It became a quiet obsession. In conference calls between ESA and NASA teams, voices strained between awe and unease. Every new observation confirmed the same impossible reality. The object entered the Earth's gravitational sphere of influence, the region where our planets' mass subtly bends the trajectories of asteroids and debris, and passed through it without deviation measurable by even our most precise instruments. No deflection, no drag, not even the faintest nod to Earth's pull. For centuries, humanity had trusted gravity as the unbroken law of the cosmos, the one constant that shaped both apple and orbit. But now, under the gaze of our finest machines, a visitor had crossed our system unbound. The silence of the universe deepened, and beneath it, an ancient question stirred again, whether the laws we call universal are truly so, or whether, somewhere out there exist travelers who answer to none. For weeks, the telescopes continued their vigil, from Hawaii to Chile, from Arizona to the Canary Islands. The faint light of 3I Atlas became a shared obsession, a cosmic riddle suspended across continents. Each new observation was a fragment of truth and contradiction. Its brightness did not fluctuate as expected from rotation, suggesting a geometry that defied ordinary spin. The reflected light carried a curious spectral hue, neither rock nor ice, more akin to something metallic or carbonized by eons of interstellar exposure. As it slipped past the inner planets, calculations revealed that even the sun's immense pull could not bend its path. The arc of its trajectory remained almost perfectly straight, a defiant line slicing through the curved tapestry of gravitational space. For scientists trained in precision, this was not merely strange, it was impossible. Every known mass in the solar system tugged on it, yet nothing registered. No measurable perturbation. It was as if 3 IATLAs existed in a subtle detachment from the space it crossed, following a map that only it could read. Theories multiplied, some cautious, others daring. Could it be a fragment of an ancient exoplanet's core, so dense that the usual models of motion failed to describe it? Or the opposite, a hollow structure, light enough to feel almost no gravitational influence at all. The extremes both felt improbable. Others whispered of radiation pressure, that perhaps sunlight itself, striking a thin reflective surface, propelled it forward. But even then, the calculations refused to align. The push of photons from the sun could not fully account for the precision of its defiance. Observatories released visualizations, simulated arcs through the solar system showing where gravity should have turned its path. Each line curved gracefully, obeying the sun's command. Yet the real data overlaid upon them was mercilessly straight, like a scar across the model of the cosmos. For the public, it was a curiosity. For physicists, it was a quiet tremor in the foundations of certainty. Within the archives of the Minor Planet Center, the coordinates of 3 IATL-AS accumulated a breadcrumb trail of the impossible. With each data point, the object moved further from the sun, accelerating slightly, as if escaping not just the solar system but the reach of explanation itself. It carried with it the enigma of its origin, a wanderer from another star, another time, perhaps from a place where gravity behaves differently, or not at all. Meetings turned philosophical. In hushed discussions, astrophysicists spoke of unseen influences, dark matter filaments, quantum vacuums, even the faint stretching of space-time by the expansion of the universe itself. Could 3I Atlas be a messenger from that unknown realm, a body whose motion exposed the subtle seams in the cosmic fabric? The more they studied it, the more it seemed to slip away, not just physically, but conceptually. Each attempt to define its behavior expanded the horizon of mystery rather than closing it. It had become a mirror for human limitation, a reminder that even in an age of powerful telescopes and precise instruments, the universe still holds the capacity to surprise, to humble, to reveal that knowledge itself has boundaries. And so the object continued outward, beyond Mars, beyond Jupiter's domain, fading into the black that had once delivered it. Its trajectory remained pure and unbent, a line through space that seemed to reject every gravitational invitation. Behind it, on Earth, computers continued to hum. Equations continued to evolve, and the oldest of forces, the one that had built the stars and held the oceans to their basins, stood questioned by a single, indifferent traveler. 3I Atlas left no sound, no signal, no trace of intention. Only its motion remained, an unspoken defiance written into the mathematics of the universe. And as the last photons reflected from its surface reached human eyes, one quiet realization settled among those who watched, that perhaps the cosmos is not governed by laws at all, but by mysteries we have mistaken for them in the imagination of physics. Earth's gravity is an ocean, vast, unseen, and inescapable. Every object that drifts too close is caught within its depths, pulled inward along invisible currents. Even the moon, enormous and ancient, forever falls toward the planet, caught in a dance of attraction and surrender. Gravity is the tide that never ends, the unseen sea that binds the cosmos together. Yet, in this endless ocean, one traveler moves untouched. If gravity is a deep trench carved into space-time, then 3I Atlas glides above its surface, not falling, not resisting, simply ignoring the pull that anchors all others. When the data first revealed this truth, it unsettled even the most grounded minds. In the language of celestial mechanics, there should have been curvature, the gentle bow of obedience that every passing body shows when touched by Earth's mass. Instead, there was defiance, a perfect, unwavering line, traced through the planetary system like a scar across the symmetry of physics. Computational models began to fail. Orbital simulators, built upon Newton's timeless equations and Einstein's elegant curvature of space-time, all broke against the same wall of data. No model could reproduce the trajectory. No perturbation, no mass distribution, no solar influence could explain why the object refused to bow. Even under the gravitational resonance of the Sun, Earth, and Moon, a triad capable of bending the path of asteroids millions of kilometers away, 3I Atlas remained sovereign. It moved as though traveling through a vacuum not of space, but of law. The analysis deepened. Spectral readings from multiple observatories suggested an unusually high albedo, a reflectivity inconsistent with known asteroid or cometary materials. It shimmered faintly in the infrared, yet gave no hint of volatile activity. No ice sublimation, no dust plume, no spin signature that would mark it as a tumbling rock. Its surface, smooth and featureless in the limited data available, reflected sunlight like polished alloy. It behaved not like a natural fragment, but like something deliberate, engineered, perhaps, or shaped by forces beyond simple collision and erosion. In the halls of the European Southern Observatory, analysts whispered possibilities that bordered on taboo. Could the object be hollow, a shell of extraordinary density designed to slip through gravity's grasp? Or could it be dense beyond known measure, composed of exotic elements, a remnant of neutron star debris or planetary core ejected from a dying system? Every answer led to another impossibility. If it were dense enough to resist gravitational influence, its presence would distort the paths of nearby debris, yet nothing around it moved. If it were light enough to remain unaffected, solar radiation would have sent it tumbling wildly, yet it flew with steady surgical precision. The paradox deepened with every hour of observation. NASA's orbital mechanics team began to test the boundaries of known physics. They modeled space-time itself around the object's path, applying general relativity's curvature, equations to search for hidden gravitational harmonies. Nothing, even when quantum corrections were applied, minuscule mathematical adjustments for the smallest scales of the universe, the anomaly persisted. It was as if the object did not exist within the same metric of space-time as everything else around it. Some scientists began to question whether this was truly gravity's failure or humanity's misunderstanding of it. Perhaps 3I Atlas was not defying the law, but revealing an extension of it, a deeper structure that Newton and Einstein had only glimpsed. In private conversations, a few theorists spoke of dark matter interactions, unseen fields that might nullify gravity's pull under precise conditions. Others proposed that the object was riding the gradient of space-time expansion itself, caught in a local wave of dark energy that rendered gravity impotent. But even these interpretations faltered beneath scrutiny. To affect only one object, to act so precisely within our system, such a field would need to be directed, intentional, and intention is not a word the universe easily tolerates. The object's stillness became its most haunting quality. Every known celestial body spins from the smallest asteroid to the largest gas giant. Rotation is nature's default, the byproduct of creation and collision. Yet 3I Atlas rotated not at all. No measurable angular velocity, no precession. It drifted through the solar system like a sculpture poised, silent and eerily self-contained dot to those who tracked it. The absence of spin felt almost unnatural. It was not behaving like something born of chaos. It was behaving like something placed as days turned into weeks. The data accumulated, and with it, a quiet unease. The failure was no longer mathematical. It was philosophical. Gravity, the one force that had never betrayed its consistency, seemed selective for the first time. It had let one traveler pass untouched, as if recognizing something beyond its jurisdiction. The question began to shift, whispered now not in laboratories but in late-night messages between observatories and research teams. Was gravity truly universal, or had humanity mistaken its reach? If there existed an object immune to its embrace, what did that say about the rest of the cosmos, about the very architecture of reality? 3. The first atlas drifted onward, shrinking in the eyepieces of telescopes, leaving behind not a trail of dust, but a scar upon certainty itself. In its wake, the universe seemed quieter, more deliberate, as though withholding its next secret for those patient enough to doubt their own understanding. And so, beneath the stars, the oldest law of nature stood questioned, not by rebellion, but by silence. A silence carried by a lone traveler that refused to fall. In the weeks that followed, the anomaly became an obsession. Telescopes across Earth turned their gaze toward the quiet intruder, their sensors reaching through the darkness for any fragment of truth. From the deserts of Chile to the frozen observatories of Mauna Kea, light from 3I Atlas was captured, split, and analyzed with reverence, as though decoding a message from the fabric of space-time itself. But light, too, refused to betray the object's nature. Its spectral lines were maddeningly plain, neither the warm tones of iron nor the deep absorption features of carbon or silicate. Instead, its reflection came back pure, almost featureless, as if mirrored. It absorbed nothing, revealed nothing, gave nothing away. An object stripped of the usual signatures of matter, hovering through the solar system like an idea made visible at the Jet Propulsion Laboratory. Models grew increasingly desperate. One proposed that the object was wrapped in a sheath of electromagnetic distortion, a kind of invisible cloak refracting starlight, bending gravity's reach in subtle ways. If true, it would suggest technology far beyond humanity's grasp. Yet when the theory was tested against radio emissions and polarization data, it fell apart. The silence persisted. 3I Atlas emitted no signals, no radiation spikes, no artificial pulse to hint at origin or intent. Still, the numbers did not lie. Its approach through the Earth-Moon system was charted to exquisite precision, and by all known physics, its path should have curved even slightly. A measurable deflection, a whisper of compliance. But the curvature never came. It passed through the gravity well like a beam of light through clear glass, neither slowed nor drawn. As if, for this single traveler, the mass of Earth did not exist. For cosmologists, the implications began to spiral. If one object could traverse space-time unbent by gravity, it meant there existed states of matter or space-time geometries untouched by Masonagi interactions. Some invoked the term gravitational transparency, a phrase that sounded poetic but carried unsettling depth. Perhaps, they said, this was not a solid object at all, but a standing wave, a frozen ripple in space-time, moving through the universe at light's command. Or worse, perhaps it was not moving at all, and it was reality itself bending around it. The philosophical weight of that idea began to press on the scientific mind. If 3I Atlas did not respond to gravity, did it exist within the same reality as the rest of matter? Or was it intruding from another manifold, a neighboring brain in the vast mathematical landscape of the multiverse? Such questions had long belonged to theory and speculation. But now, for the first time, an observation pressed against the veil, and still it moved. Its course would carry it beyond Mars by spring, past Jupiter's orbit by the following year, and into the cold void beyond Saturn soon after. No propulsion, no cometary decay, just steady, absolute motion, in the data rooms where the last traces of its passage were being archived. There was a quiet resignation. Humanity had not solved the mystery. It had merely confirmed that one existed. 3. The first atlas was vanishing into interstellar darkness again, taking its silence with it. Yet, long after its signal faded from the detectors, the question it left behind continued to echo, not as a challenge, but as a revelation. Gravity had not failed. It had revealed its limit, the edge of its dominion. And beyond that edge, perhaps, lay a domain where the rules were not written for planets and stars, but for something else entirely. The cosmos had offered a glimpse, fleeting, unyielding, of a truth older than matter. And as 3I Atlas slipped back into the interstellar sea, humanity stood on the shore of understanding, watching the ripples fade into the dark and wondering if, somewhere beyond the pull of all things, something was watching back. For centuries, humanity has lifted its eyes to the dark, searching for meaning in the movements of light. In the age of Galileo, a simple tube of glass revealed the unseen moons circling Jupiter, craters etched across the lunar face, a universe alive with motion. Each discovery expanded not only the heavens, but the human spirit itself, compelling the next generation to build sharper lenses, larger mirrors, and, eventually, machines that could watch the sky without rest. The lineage of those watchers forms an unbroken thread through time, a tapestry woven from curiosity and light. From the mountaintop domes of the 20th century to the all-seeing arrays of the modern era, each instrument has served as humanity's extended eye, straining against the boundaries of night. The Pan-STARRS telescope in Hawaii became one of the latest heirs to that legacy. It does not gaze, as humans once did, through a single eyepiece. It surveys the heavens by algorithm, comparing pixel to pixel, frame to frame, hunting for the faintest flicker of motion among the still stars. A machine that dreams in data, scanning the sky for anomalies that whisper of journeys not begun within our solar cradle. It was on one such night, in the spring of 2025, that the pattern emerged. A dim point of light moved ever so slightly between two exposures, faint, fast, and yet oddly deliberate. At first, it was catalogued without urgency, another trans-Neptunian object, perhaps, or a minor comet wandering too close to the inner system. But as the data deepened, the orbit did not resolve. The numbers refused to fold into the familiar language of ellipses. Its path curved outward, not inward. It did not belong. Astronomers at Pan-STARRS rechecked the feed. They pulled every nearby observation from archives, Catalina, MT, Lemon, Atlas, together. The dots formed a trajectory that defied the quiet arithmetic of gravity. It was the third of its kind ever found, following 1I Oumuamua and 2I Borisov, and so it was given a new name, 3I Atlas, the third interstellar interloper to trespass into the sun's domain. But something about this one was different. Where Borisov blazed with cometary exhaust, and Oumuamua tumbled like a shard of rock or metal, 3I Atlas moved with an unnerving calm, smooth, unspinning, almost mathematical in its precision. The early velocity calculations were unsettling. It approached the solar system at speeds consistent with interstellar drift, but once inside, it did not slow. No gravitational signature from the sun or the planets registered as significant. It was as if the very field that governs celestial motion had forgotten this one traveler. In the cold hum of the data servers, astronomers gathered in digital silence, their screens filled with graphs, orbits, and uncertainty. Each line of code and light curve spoke to centuries of human effort, generations of eyes that had built this moment. And yet, for all that history, for all the refinement of technology, They were witnessing something no telescope was ever designed to understand, an object that seemed to exist outside the grammar of motion itself. At observatories around the world, the alert rippled outward. The European Space Agency's Gaia database cross-referenced the coordinates. NASA's Deep Space Network adjusted its sensitivity for potential radar echoes. Amateur astronomers in Chile, Namibia, and Japan aimed their instruments skyward, hoping to catch even a glimmer before dawn. Each observation added another pixel of clarity to the unfolding enigma, but with each new measurement came a deepening unease. Its course remained fixed, unwavering, linear. The gravitational model of our solar system, a cathedral of mathematics built over 4 centuries, could not bend this visitor's motion to its will. In that collective stillness, one could almost feel the echo of Galileo's heartbeat, that same tremor of realization when the universe revealed it was not built around human expectation. The first atlas was not merely another stone wandering between the stars. It was a messenger from the outside, indifferent to the forces that bind worlds and suns alike. And beneath the quiet hum of observation, a subtler truth emerged. Every telescope, every mirror, every pixel of silicon etched in pursuit of understanding, all had been born from the same yearning, to know what holds us in place, and what might exist beyond that hold. Yet here, in a single faint speck of light, was something that seemed to belong to neither gravity nor time. As the nights passed, and the object crept steadily across the celestial grid, astronomers began to understand that this discovery was more than a scientific milestone. It was an encounter with the limits of perception itself, a glimpse beyond the reach of the sun, and perhaps beyond the reach of human comprehension. In that realization, the discovery of 3I Atlas became something larger than data or theory. It became a reflection, a mirror held up to the oldest question in human history. How much of the universe truly obeys the same laws that keep our feet on the ground? The watchers of the sky, from Galileo to Pan-stars, had spent their lives tracing the architecture of motion. But this time, they had found not a body in orbit. They had found the boundary of understanding itself, drifting quietly through the dark in the quiet hours that followed the first confirmed orbit of 3I Atlas. A different kind of tension spread across the global scientific community, not the excitement of discovery, but the disquiet of contradiction. For decades, the mathematics of celestial motion had been an unbroken covenant between observation and law. Every planet, every comet, every drifting grain of dust submitted to the will of gravity with predictable obedience. Yet this object moved through that ancient harmony as though deaf to its song. In laboratories and observatories, the hum of machines was replaced by the quiet rustle of unease. The data were real. The parallax shifts, the Doppler velocities, the consistent readings across independent telescopes. The numbers were clean, almost elegant, and therein lay the discomfort. Nothing in the data appeared wrong. It was reality itself that had become suspect. At the European Southern Observatory, a team led by orbital dynamicists attempted to refit the path using modified Newtonian mechanics. They adjusted for radiation pressure, non-gravitational thrust, even hypothetical jets invisible to infrared detection. Yet the trajectory held firm. No matter how they bent the equations, the line refused to curve. NASA's Jet Propulsion Laboratory, equally cautious, ran their own simulation across supercomputers that could map every known gravitational influence within 100 million kilometers. Still, the deflection remained negligible, far below measurable tolerance. When the report was quietly circulated among institutions, a single line in the summary drew collective silence. No known physical interaction accounts for the observed trajectory. Those words, clinical and brief, carried the weight of something almost heretical, a suggestion that perhaps, for the first time, gravity had encountered something beyond its reach. In the public domain, the story began to ripple outward in controlled tones. Press releases framed it as a unique interstellar visitor exhibiting anomalous motion, careful to avoid speculation. Yet within the closed halls of research, conversations grew more candid. Could 3I Atlas be composed of exotic matter, particles that interact weakly or not at all with baryonic mass? Such material, if it existed, might drift through planets, stars, even black holes, untouched and untouching. Others invoked the possibility of a macroscopic quantum body, a structure frozen in a coherent state that allowed it to bypass the usual tug of space-time curvature. The language of physics began to edge toward philosophy, as it often does when the frontier trembles. Amid this uncertainty, the human element persisted. Long nights of observation, the slow exhaustion of tracking a vanishing signal across a turning Earth. Graduate students stared at flickering graphs until their vision blurred, while senior astronomers argued softly over calibration data and atmospheric corrections. There was a strange poetry to it, a planet full of minds straining to understand an object that refused to notice them. The hum of servers, the static of radio telescopes, the faint pulse of coordinates transmitted across continents, all of it became the heartbeat of a civilization, briefly united by bewilderment. Meanwhile, the Vera Rubin Observatory prepared to join the search. Its wide-field cameras, capable of capturing the entire southern sky in a single sweep, were calibrated to look for objects just like this. But even as its sensors aligned, the object was already slipping away, receding into a darkness from which it had come. Data windows were shrinking, observation arcs collapsing into uncertainty. For many, the realization arrived like a quiet grief. This encounter, this fleeting brush with something alien to physics, might soon be over. Yet in that fading light, something profound had already occurred. Humanity had glimpsed the fragile perimeter of its understanding, and for a moment, it trembled when the final coordinated measurements arrived, a handful of faint detections from the Atacama Ray and one from a Japanese observatory beneath a clouded sky. The collective picture was complete. The first Atlas had crossed Earth's gravitational boundary without measurable influence, its path a perfect line slicing through the curved fabric of spacetime. It neither fell toward the planet nor away from it. It simply continued, silent and indifferent, as though gravity itself were a myth it had never learnt to believe in. In that stillness, the world's instruments finally went quiet. The object would not be seen again for generations, perhaps ever, but in its wake, it left more than mystery. It left a question older than science, older than thought itself. What if the universe contains regions, entities, or principles that exist entirely outside the frame of interaction, realities immune to the forces that define existence here? And if so, was 3I Atlas merely a traveler passing through, or a reminder that the cosmos may not be a single, unified system after all, but a mosaic of incompatible truths? Thus the chapter of discovery closed not with revelation, but with silence, a silence heavy with the awareness that knowledge, like light, only illuminates what it can reach. Beyond that radius lies the infinite dark, where objects like 3I Atlas move unbound, untouched, and unseen, indifferent to the gravity that shapes all else. When the first peer-reviewed confirmation arrived, stamped, signed, and quietly uploaded to an online archive, it struck the scientific world like a silent detonation. No press conference, no countdown. Just a few lines of technical prose. Object 3, I-Atlas, exhibits an anomalous trajectory, inconsistent with gravitational deflection by Earth. Within hours, that single sentence had circled the globe, its implications unraveling in every language of science and speculation. For astronomers, it felt like déjà vu, a haunting echo of Oumuamua's inexplicable acceleration years before. But this time, there was something different, something colder. Oumuamua could be argued away as outgassing a push from evaporating ice hidden beneath a crust of carbon. But 3I Atlas offered no such comfort. There was no jet, no spin, no glow of sublimating vapor, only stillness, only motion that should not be, inside institutions that had long served as temples of reason. Harvard, Caltech, the Max Planck Institute, the European Southern Observatory. Emails flooded across servers faster than the object itself was moving. Theories clashed like waves on rock. Measurement error, one group insisted, perhaps atmospheric distortion or misaligned calibration. Others countered with data from vacuum-based instruments, impossible to dismiss. A third camp whispered of yet undetected propulsion, a residual effect of interaction with the solar wind, or even the influence of dark matter halos, the unseen scaffolding of galaxies brushing faintly against local space-time. But none of these explanations fit the precision of the data. The numbers were stubborn. The numbers were indifferent. Orbital physicists convened digital roundtables, passing through equations as though trying to decipher scripture. How could gravity, that ancient constant, that unbroken covenant between mass and motion, appear to fail on any scale? Some argued that the object's surface area-to-mass ratio was simply too extreme, rendering gravitational influence negligible. Perhaps it was hollow, a fragment of ultralight material drifting through the cosmos like cosmic foam. But then came the troubling corollary. Such a structure could not have survived the interstellar medium intact. Dust, radiation, micrometeoroids, the brutal friction of eternity would have shredded it long ago. And yet here it was, pristine, untouched, indifferent to both gravity and time. Beyond the observatories, the reaction spread like a cultural wildfire. News headlines flared in hyperbole. Earth's gravity just failed. The object that ignored the sun, are the laws of physics breaking? Scientists recoiled from such drama, yet found themselves unable to quell the fascination. For the first time in years, the public's gaze turned upward again, not in fear, but in awe. Commentators debated whether this was a herald of discovery or an omen of ignorance, while online forums pulsed with speculation ranging from alien craft to interdimensional debris. Even as astrophysicists dismissed such claims, the idea lingered, fed by the object's quiet refusal to behave like anything known behind the public theater. However, there was another current, quieter, more human: pride, rivalry, curiosity sharpened by the ache to be first. Private aerospace firms, university labs, and national agencies all began building competing models of 3I Atlas's behavior. NASA's Frontier Dynamics Division ran simulations on distributed quantum processors, while ESA's Gravitational Mapping Team reanalyzed decades of planetary trajectory data, searching for overlooked anomalies that might explain the phenomenon. Even China's Purple Mountain Observatory joined the fray, pooling resources with amateur astronomers in an unprecedented collaboration that blurred the line between professional and citizen science. For a brief moment, the world's intellectual frontiers aligned in shared uncertainty, yet beneath the algorithms and equations, a deeper anxiety was taking shape. If gravity could fail even once, What else might falter in the cosmic order? Could the constants of nature themselves fluctuate across space and time? The notion seemed absurd, heretical even. Constants were the foundation upon which reality was built. If one crumbled, the entire edifice of physics would tremble with it. But there was the data, blinking like an accusation from across the void. Perhaps, some whispered, this was not a failure of gravity, but a revelation of its limits. Maybe gravity was never universal, only local. Maybe the cosmos operated in layers, regions where the rules shifted, tuned to dimensions that humanity could neither measure nor imagine. In the midst of these intellectual tempests, a small group of theoreticians proposed a daring interpretation. What if 3I Atlas existed in a kind of duality simultaneously within our space-time and outside it? A structure woven from exotic matter that coupled weakly to the Higgs field, rendering it effectively massless in our reality, yet still real in another. It was a theory as fragile as it was extraordinary, but it spoke to something primal in the human need to explain. Every generation had faced its anomaly, the orbit of Mercury, the bending of light, the expansion of the universe. Each mystery had reshaped understanding, never destroyed it. Perhaps, they reasoned, 3IATLAS was the next step in that lineage, the next boundary the cosmos offered to those willing to look. But not everyone was comforted by that thought. For some, the idea that gravity, the oldest, most faithful force, could be incomplete was not a challenge to solve, but a loss to mourn. It was as if the universe had whispered back, "You do not yet understand the rules of the game." And in the long nights that followed, as observatories tracked the fading signal of the interstellar wanderer slipping beyond reach, the scientific world found itself suspended between wonder and unease, standing at the fragile intersection of knowledge and mystery, staring into the dark where even gravity dared not follow. In the following weeks, the reverberations of 3IATLAS's defiance spread far beyond the orbit of academia. Government agencies held closed-door meetings, not because they feared invasion, but because they feared ignorance. The idea that something could drift through the gravitational influence of Earth, the same invisible force that anchors oceans and moons without deviation, unsettled the very hierarchy of certainty upon which science and civilization rests. There was no alarm, no official panic, only a quiet recalibration of tone, memos that began with unknown parameters, proposals marked further study required, and conversations that trailed off into thoughtful silence. The world's brightest minds had encountered not danger, but something far more profound, an indifference from the cosmos, so total that even the laws of nature seemed negotiable. At the International Astronomical Union, an emergency symposium was convened under the neutral title Anomalous Trajectories and Non-Newtonian Deviations in Transient Objects. Delegates arrived, sleepless, many having traveled from night shifts at their observatories. The atmosphere was electric, a mix of exhaustion and reverence. On screen, the trajectory of 3I Atlas arced across 3 dimensions, a line of light slicing through the modeled curvature of Earth's gravity well, like a blade through mist. No matter how many times the parameters were adjusted, whether for solar wind, albedo variation, or relativistic correction, the result was the same. The line did not bend. For a moment, the room was silent. Then, as if the realization needed sound to exist, someone whispered, "We're looking at the first known object that gravity forgot." Outside the scientific circles, a new kind of fascination took hold. Media networks, long starved for wonder, untainted by catastrophe, began framing the mystery as a cosmic drama, the story of an unbound traveler, a rebel against the universe's oldest rule. Documentaries aired simplified simulations, showing Earth's gravity well rendered as a deep funnel of light, with a single thread, the path of 3IATLAS, cutting through it undisturbed. Artists painted it as a shard of alien glass, glowing faintly as it crossed the solar system's invisible boundaries. Musicians wrote compositions inspired by its silence. Even poets found language for it, describing the object as a thought the universe forgot to erase. What began as data was becoming myth, and narrative humanity had always needed a mystery to remind it of its smallness. But, within the observatories, myth was replaced by an ache for explanation. Some scientists began to look backward, searching archives for missed patterns. Had other interstellar bodies, even those dismissed decades ago as measurement noise, displayed similar deviations? Teams reanalyzed data from Oumuamua, finding faint echoes of non-gravitational motion that had once been attributed to gas jets. Others studied the passage of 2I Borisov, noting that its behavior, though largely conventional, contained subtle fluctuations near Paris. Slowly, a thought began to emerge, an uneasy hypothesis that perhaps interstellar objects are not merely visitors, but messengers from regions of space where the constants of physics have slightly drifted. If the speed of light, or the gravitational constant, varied even fractionally beyond the galactic core, then an object forged under those conditions might behave in ways unfathomable here in theoretical physics journals. Papers began to appear with titles that sounded less like mathematics and more like prophecy. Variable gravitational coupling in non-local domains, weak interaction, transparency in interstellar relics, and the quietly radical local failure of universal invariance. Many were speculative, even fantastical, yet none could be dismissed outright. Each one, in its own way, whispered the same unsettling possibility that the universe might not be governed by one set of laws, but by countless regional dialects of reality, each fluent only within its own horizon. 3I Atlas could be a fragment from one such domain, a traveler fluent in a language of physics. The solar system could not translate. By the time the object began to fade from optical range, the debates had mellowed into reflection. There were no definitive answers, no triumphant equations, only a shared understanding that something extraordinary had brushed against the edges of perception and passed through untouched. For scientists who had devoted their lives to certainty, it was humbling. For those attuned to the poetry of discovery, it was holy. In the quiet aftermath, papers were filed, instruments recalibrated, and the world resumed its turning, yet something intangible had changed. The mystery of 3I Atlas lingered not as a problem to be solved, but as a reminder that the universe remains vastly more than the sum of its equations. Long after the last detection was logged, astronomers continued to step outside between shifts, gazing up into the darkness, knowing that somewhere beyond sight, that indifferent traveler continued its straight, unbroken path. And in that thought, in that haunting, humbling stillness, the boundaries of human understanding seemed, for a moment, to tremble. For days, then weeks, observatories around the world turned their most sensitive eyes toward the enigmatic speck, named 3I Atlas, a visitor moving with the calm indifference of something not bound by any rule humans understood. The first step in any investigation was simple: shine a light, bounce a signal, and listen for the echo. But when the radar beams went out, thin, invisible fingers of microwaves stretching across millions of kilometers, nothing returned. The object seemed to absorb or scatter radio waves in patterns no model could reproduce. To radar, it was a ghost, a silent silhouette slipping through the void. Some suggested its surface might be porous or fractal, capable of diffusing energy across microstructures smaller than a wavelength. Others whispered of exotic materials, carbon aerogels, metallic lattice, or something engineered for stealth. But the truth was simpler and more haunting. No one knew what it was made of, or why it refused to speak back. When optical telescopes took over, the mystery only deepened. The object's light curve, the subtle rhythm of its brightness as it rotated, did not match any known rotational behavior. Natural asteroids tumble, comets flicker, dusted by jets of ice and sunlight. But 3IATLAS pulsed irregularly, as though reflecting from facets that shifted not with spin, but with some unseen internal geometry. The data suggested edges, sharp planes, where no erosion should exist. Yet these vanished from one observation to the next. One night, its albedo hinted at polished metal. The next, at dark basaltic stone. Some began to theorize that the light curve was not revealing a surface at all, but in effect, a reflection of its interaction with the interstellar medium, like ripples shimmering off a hidden field in the corridors of theoretical physics. The discussions grew both wondrous and uneasy. Radiation pressure was revisited, that faint push from sunlight which could, under the right design, accelerate an object without fuel. The numbers matched in fragments, an ultra-thin structure, perhaps no thicker than a human hair, could achieve the kind of stability observed if its area-tummus ratio was extraordinarily high. It was the same principle that had driven concepts of solar sails, vast, reflective sheets, propelled by starlight, but scaled to an interstellar magnitude. Could 3I Atlas be such a sail, launched from a distant civilization, or formed naturally in the atmospheres of dying stars where metals condense into sheets under radiation stress? A hypothesis emerged, fragile yet intoxicating. Perhaps this was not an asteroid at all, but a shard of cosmic technology adrift between suns to test such an idea. Scientists looked toward their instruments, the Parker Solar Probe, the Vera Rubin Observatory, the European Space Agency's Gaia mission, each capable of capturing hints of the object's behavior. Yet time, as always, was the enemy. The first Atlas was moving fast, faster than any intercept could manage. Even the most ambitious projections showed that by the time a probe could be designed, launched, and aligned, the object would be well beyond the heliopause, the invisible boundary, where the sun's influence fades into the galactic medium. It was a cruel truth of cosmic discovery. By the time humanity learns something exists, it is already gone. In the face of that inevitability, attention turned to the data that did exist, faint, imperfect, yet priceless. A small subset of the astronomical community began treating the object not as a lost opportunity, but as a riddle whose answers lay hidden in the details already gathered. Deep learning algorithms combed through the light curves, spectral readings, and orbital measurements, searching for anomalies that matched nothing in recorded history. The models returned strange correlations, fluctuations that aligned with solar wind density, with cosmic ray spikes, even with variations in interplanetary magnetic fields. It was as if 3I Atlas was responding not to gravity or radiation, but to something subtler, the quantum fabric that underpins space itself. At NASA's Jet Propulsion Laboratory, a handful of theorists began to explore a radical idea. What if the object's movement wasn't defying gravity, but surfing it? In certain relativistic models, gravitational waves can create microcurrents, subtle distortions in space-time that propagate through the galaxy. If 3IATLAS possessed a structure capable of resonating with these fluctuations, it might move in perfect harmony with the underlying field, effectively bypassing the gravitational pull of nearby masses. Such motion would appear from the limited human frame of reference as a failure of gravity, when, in fact, it was the purest possible form of motion, effortless, natural, timeless. As the days turned to months and the object slipped beyond the outer planets, it began to fade from public consciousness, but not from the minds of those who had watched it. They knew that every once in a lifetime, the universe reveals a truth that cannot yet be understood, a message written in a language still beyond comprehension. 3. The first atlas became such a message. The failure of radar, the erratic reflections, the unyielding trajectory, each a stanza in a poem, written by something that may not even recognize humanity as its audience. In the end, the silence of 3 IATLAS was not emptiness, it was eloquence. Its refusal to yield to inquiry was a kind of cosmic humility, a reminder that the deepest mysteries do not shout, they whisper. And as the object receded into the infinite dark, it carried with it more than unanswered questions. It carried the haunting awareness that somewhere out there, beyond the reach of our instruments, the universe still keeps secrets, not because it wishes to, but because we have not yet learned how to ask the right kind of silence to speak. Weeks turned into months, and the object that once filled the feeds of every observatory began to retreat into the cold expanse, its trail thinning like a fading note in a cosmic symphony. Yet for those who had been part of its discovery, 3I Atlas lingered in their thoughts like a haunting refrain. Late nights at the European Southern Observatory were spent reprocessing light curves pixel by pixel, stripping noise from the signal, searching for any trace of structure hidden within the faint gleam. When the data were filtered enough to approach the edge of what could be trusted, faint modulations appeared, minute oscillations in brightness that repeated at irregular intervals. They were too slow to be spin, too precise to be random. Some wondered if these were not reflections at all, but emission subtle energy pulses interacting with the solar wind. Instruments tuned to plasma frequencies began to monitor for anomalies, and once, only once, a faint spike was detected. It was never repeated, but it was enough to fracture certainty once more. In the months that followed, the story of 3 IATLAS became less about the object itself and more about what it revealed in humanity. It forced scientists to look again at the assumptions buried deep in their equations. Gravity, once the serene constant binding everything, now felt like a question with an unfinished sentence. If an object could pass through Earth's gravitational influence untouched, what did that say about the completeness of general relativity? Papers emerged cautiously, written in the guarded tone of scientists aware they were treading on the edge of speculation. Some proposed that at certain energy densities, gravity might experience localized anomalies, quantum fluctuations on macroscopic scales. Others pointed toward dark matter, suggesting 3I Atlas might possess a field of exotic particles that counteracted gravitational curvature. A few whispered of engineering beyond comprehension, structures tuned to manipulate inertia itself. Each theory was elegant, and each dissolved under the weight of insufficient evidence. Outside the academic halls, artists, philosophers, and poets found their own meaning in the enigma. They spoke of the visitor as a mirror held up to human limitation, a reminder that even in an age of telescopes that see galaxies being born, the cosmos can still hide something in plain sight. Documentarians replayed the discovery footage, slowing it down frame by frame, narrating over the faint pixel that once crossed the CCD sensor. The voiceovers spoke of humility, of wonder, of how a civilization's greatest strength might not be its understanding, but its willingness to dwell in unknowing. In classrooms, professors turned 3I Atlas into a parable, teaching students that science is not a fortress of facts, but a horizon forever moving away as knowledge advances. And somewhere beyond Neptune's orbit, the object continued its silent voyage. No one knew if it was tumbling or gliding, if it carried within it a core of rock, metal, or something neither. The sun's light grew weaker upon its surface until even the most powerful telescopes could no longer track it. The final recorded observation, barely above the noise threshold, captured it against a backdrop of dim stars. A single point of light almost indistinguishable from the cosmic sea. Then it was gone. From that moment on, 3I Atlas existed only in numbers, in memory, and in the quiet ache of unanswered curiosity. In the aftermath, committees proposed dedicated interstellar interceptors, autonomous probes capable of launching within weeks of a new detection, riding gravitational assists to catch the next visitor. The funding was uncertain, the technology embryonic, yet the determination was real. Humanity had learned from its silence. It would not let the next one pass unseen. For while 3I Atlas had taken nothing tangible, it had left behind something immeasurable, the rediscovery of cosmic awe. It reminded those who watched that the universe is not merely a field of data points, but a living mystery, a place where even the most disciplined logic must sometimes kneel before wonder. As the object vanished into interstellar night, a kind of collective stillness followed. The world resumed its rhythm. The headlines shifted. Yet, in quiet observatories under thin, cold air, a few still stood by the monitors long after the data feeds had ended. They stared into the static, hoping for a flicker, a return signal, a whisper from the edge. None came, but perhaps that, too, was the message. Some truths arrive not to be solved, but to remind us that there are still edges left in the map of the known, still frontiers where the laws of nature hold their breath, and beyond them, the infinite silence of what remains to be found. At the farthest reaches of what can be proven, where equations fray into silence, uncertainty dissolves into wonder, science begins to resemble poetry. It is here, at the edge of comprehension, that the enigma of 3I Atlas now resides. The known laws of motion, gravity, and matter were written to describe a universe that behaves predictably. Yet this visitor, gliding across that framework without bending to it, now forces humanity to look again at the scaffolding beneath reality itself. What if, some wondered, this was not an ordinary object of rock or ice, but a relic of a physic still unborn? In the quiet rooms of theoretical research centers, conversations turned to forms of matter long imagined but never found. Could 3I Atlas be composed of exotic particles, materials that react to gravity not with attraction but with defiance? Physicists spoke of negative mass, a strange mirror concept where pushing an object makes it move toward the source of the push, not away from it. If such matter could exist, it would generate a kind of gravitational repulsion, a counterfield to the familiar pull that shapes stars and planets. It would glide through the solar system as 3I Atlas had done, immune to deflection, riding the cosmic currents as if gravity were nothing more than a faint breeze. But the equations that allow such matter also destabilize the very structure of relativity. Negative mass, though possible in theory, would collapse into paradox under observation. No experiment has ever found a trace of it, no cosmic ray, no quantum fluctuation, no laboratory anomaly. And yet, the motion of 3I Atlas whispered that something beyond standard mass must be at play. Others suggested a subtler form of exoticity, mirror matter, a shadow version of the visible universe, predicted by symmetry theories that attempt to unify physics' most broken halves. If the object were composed of such material, it would scarcely interact with electromagnetic fields, making it nearly invisible except for the sunlight it faintly scattered. That, too, fit the data. There were those who ventured further still, linking the mystery to the universe's most elusive substance, dark matter. It is known that nearly 85% of the universe's mass is invisible, its presence revealed only through gravitational influence. But what if a fragment of this hidden majority had, by chance or by cosmic design, wandered into the light of the solar system? Some simulations hinted that a dark matter composite, dense and unreacted, might behave in ways indistinguishable from 3IATLAS, unaffected by planetary gravity, unperturbed by the sun's pull. If this was true, it was not a failure of gravity, but a glimpse of its counterpart, the unseen skeleton of the cosmos, moving through the visible world. Yet the puzzle deepened. The faint irregularities in 3IATLAS's trajectory hinted that it was not merely resisting gravity, but interacting with it in some hidden way. One paper proposed that at relativistic velocity, the object might distort the curvature of space-time around itself, creating a localized lensing effect that bent its path outward, like a stone skipping over the surface of a gravitational pond. In this interpretation, gravity had not failed. It had been outwitted. The object was not defying physics. It was navigating it at a level beyond human comprehension, perhaps harnessing effects only hinted at in the mathematics of general relativity. The conversation turned speculative, almost philosophical. Could an object of this kind possess a field structure that mimics the effect of dark energy, the mysterious force driving the universe's expansion? If 3IATLAS carried even a trace of that repulsive energy, its motion might not just reflect the laws of our local space, but the deeper engine that shapes the cosmos itself. In that sense, it would not be an intruder, but a messenger, a tiny emissary of the same power that tears galaxies apart across billions of light years. And still, there were voices that asked a quieter question. What if this was not natural at all? Not an asteroid, not a comet, not a rogue shard of dark matter, but something crafted. The geometry of its light curve, the strange regularity of its reflection patterns, seemed to hint at design, not chaos. Could 3IATLAS be an artifact from a civilization that had mastered the manipulation of gravity, or abandoned it entirely? To imagine such a thing was to cross from physics into myth. Yet in the long history of science, many myths had later become discoveries. The debate stretched into the night, glowing screens casting pale light on the faces of those who dared to theorize. No one agreed, and perhaps no one wanted to, for the beauty of 3IATLAS lay not in answers, but in the questions it forced back into the human heart. What if gravity, the most dependable of forces, was not universal after all? What if there existed regions of the cosmos where the fabric of reality flowed differently, where the rules of motion and mass were rewritten? Perhaps 3IATLAS had come from such a place, a region of the universe shaped by a physics still unimaginable to us. In the end, the data could not confirm any theory. The object was gone, and with it, the hope of direct proof. What remained were traces, equations that no longer aligned, reflections caught in the mirrors of speculation, and a deepening sense that the boundaries of science are not made of walls, but of fog. Beyond that fog, something moves, something that may yet redefine what it means to fall, to move, to exist. And for a brief moment, humanity had watched it pass, as the last observations of 3IATLAS faded into the static of the cosmos. What remained on Earth was not closure, but a profound and growing unease, the awareness that a mystery had slipped through human comprehension, leaving behind a disturbance in the collective understanding of physics. In the months that followed, research papers multiplied across astrophysical journals, each one stretching the boundaries of accepted theory in search of coherence. Some dared to apply modifications to Einstein's general relativity, introducing new tensors and untested coupling constants, attempting to describe what the universe would look like if gravity's influence could be selectively muted. Others examined the object's path through the solar system from the perspective of quantum field interactions, exploring whether 3I Atlas had somehow traversed regions where space-time itself behaved differently, regions where gravity strength might be locally diminished by the influence of vacuum energy or higher dimensional effects. For some theorists, the anomaly became a testing ground for long-standing speculative frameworks, Mond-modified Newtonian dynamics, TeVs, and emergent gravity. In those models, gravity is not a fundamental force, but an emergent property of information embedded in spacetime, an entropic reaction of the universe itself. If that were true, then perhaps 3I Atla was not immune to gravity, but simply existed outside the conditions that generate it. Like a ripple traveling through waterless air, its motion could be a sign of matter behaving in a state uncoupled from the familiar thermodynamic web that binds all other objects. The implication was staggering, that gravity might not be constant across all realities, but a local phenomenon, a kind of cosmic language that most of the universe speaks, but not all. Some physicists, unwilling to venture so far into abstraction, turned instead to energy, density, and material composition. They proposed that 3I Atlas might be composed of ultra-dense, crystalline quark matter, a theoretical state of baryonic material compressed beyond the stability of neutrons. Such an object would be unimaginably compact, small enough to evade detailed observation, yet massive enough to resist tidal deformation. But even then, its straight-line trajectory made no sense. Gravity does not negotiate, it dictates. And still, this visitor had moved as though the universe's most sacred law were optional. Others speculated that the body might have carried within it a quantum field that interacted repulsively with gravity, a localized form of negative energy density, the kind proposed in theoretical wormhole physics. If such a field could exist naturally, it would allow an object to surf on space-time curvature rather than being pulled into it, gliding along gravitational gradients like light refracting through glass. The deeper the speculation went, the thinner the distinction became between science and philosophy. Some wondered if the failure to explain 3I Atlas said more about human perception than the object itself. Perhaps gravity had not failed. Perhaps understanding had. For centuries, scientists had assumed that the universe's laws were uniform, that the same equations held true from the edge of an atom to the edge of a galaxy. But what if that assumption was only an approximation? If space is not a fixed stage but a living field, then there might exist conditions, rare, hidden, unimaginable, where the rules shift. Maybe 3I Atlas had passed through one such threshold, carrying with it the signature of a place where gravity is not what it is here. Meanwhile, deep within CERN's theoretical division, a small group of physicists ran numerical simulations of relativistic trajectories through higher dimensional space. Using the mathematics of brain cosmology, they modeled how a body could appear to move unaffected by gravity if it was slightly displaced into another dimension, a bulk parallel to our own. The simulations suggested that even a tiny shift in dimensional alignment could reduce an object's gravitational coupling by orders of magnitude. The idea was impossible to test, yet mesmerizing, that 3I Atlas was not just moving through our universe, but across it, a shadow cast by a mass existing partly elsewhere, And still, amid all this, there were those who refused to abandon the dream that this anomaly might be more than a random event. In hushed tones, at conferences and symposia, the question arose again and again: what if it was deliberate? What if the object had been designed to exploit the fabric of space-time, not to travel through it, but to slip between its folds? If so, its resistance to gravity might not be a failure of natural law, but a demonstration of its mastery. That possibility lingered like a quiet revelation, not an assertion, but a whisper that somewhere beyond the thin boundary of what can be observed, there may exist beings or systems that no longer struggle against the pull of the universe, but have learned to live free of it. By the end of that year, the first atlas had already left the heliopause, vanishing into interstellar silence. Yet its legacy endured, not as a mystery to be solved, but as a mirror held up to the limitations of human certainty. It reminded the watchers on Earth that the frontier of science does not end with proof or disproof, but with the humility to recognize when the cosmos has spoken in a language still unknown. And in that humility, something ancient stirred, the same awe that once drove early astronomers to lift their eyes toward the sky and wonder not how the heavens moved, but why they could not look away. In the months following the vanishing of 3IATLAS, the scientific world shifted from wonder to calculation. The observatories that once gazed in awe now turned toward simulation, trying to recreate what had just slipped beyond their reach. At the heart of every discussion was a single, grounding conviction that the universe, no matter how strange it appeared, must still obey its own laws. The mystery, they argued, was not that gravity had failed, but that human perception had. Nature does not break its own rhythm. It only hides its subtler notes behind the noise of distance and time within. NASA's Jet Propulsion Laboratory and the European Southern Observatory, teams of astrophysicists began to revisit the data, aligning every known constant, cross-checking every spectral reading. Theorists pointed to a familiar precedent: Oumuamua, the first known interstellar visitor detected in 2017, which had to show signs of unexplained acceleration without a visible tail. Back then, some proposed exotic explanations: alien probes, light sails, or fragments of cosmic technology. But as the years passed, the consensus evolved into something more restrained, though no less fascinating: that Oumuamua's push might have come from outgassing jets so faint they escaped detection. Carbon dioxide or hydrogen, sublimating invisibly from its surface, could have provided a subtle thrust, bending its path just enough to mimic defiance against gravity. And so, when 3I Atlas appeared, the rational mind of science sought familiar ground. Perhaps, once again, the culprit was natural, an unseen jet, a sliver of evaporation too weak for even the Webb telescope to catch. Yet, something about Atlas refused to fit neatly into that box. Its light curve, recorded over weeks of observation, showed none of the brightness fluctuations typical of tumbling objects. Its motion was smooth, unnervingly precise, like a fragment guided by an internal compass rather than random rotation. Some researchers proposed that the object's shape, long, thin, and possibly coated in reflective carbon compounds, could have produced a self-propelling effect under the pressure of solar radiation. Sunlight itself, they suggested, might have acted as a microscopic sail, pushing Atlas along its path in perfect balance. That hypothesis, though elegant, strained under scrutiny. For radiation pressure to account for the observed acceleration, Atlas would need to be paper-thin, a wafer of cosmic material no thicker than a few millimeters, yet hundreds of meters across. Nature, as far as human knowledge extended, did not build such things. And yet, its trajectory persisted, forcing physicists into the uncomfortable space between what was possible and what was probable. They began to construct digital analogues of the object, feeding the data into higher resolution simulations. Each model spun faster, brighter, more fragile than the last, until finally one matched the observed dynamics. A shard of carbon-rich silicate fractured from a young, volatile exoplanet during its formation and cast into interstellar darkness billions of years ago. In that version, 3I Atlas was not a deliberate traveler, but a relic, a splinter of creation wandering through the Milky Way over eons. Radiation from nearby stars could have burned away its volatiles, leaving a hardened shell that gleamed like obsidian in sunlight. When it entered the solar system, the residual heat of its passage may have caused tiny patches of frozen gases beneath its crust to sublimate, generating faint, invisible jets that altered its path just enough to baffle gravitational predictions. A ghostly propulsion, undetectable yet real, the whisper of physics, not its absence. But even this theory demanded faith in the unseen. No telescope had captured a trace of vapor. No spectrometer had identified volatile compounds. The scientific consensus grew cautious, then divided. Some clung to the elegance of natural mechanics, unwilling to let a single anomaly shake the bedrock of celestial motion. Others sensed something deeper, not supernatural, but uncharted. If gravity remained constant, then perhaps other forces had simply gone unnoticed. Could electromagnetic interactions, quantum vacuum effects, or photonic recoil all conspire in ways too subtle to measure? Could reality itself possess a complexity so fine that even the instruments built to detect the universe's faintest signals were blind to it? In the quiet halls of research institutes, amid the glow of simulation monitors and the faint hum of cooling systems, a new kind of humility began to take root. Scientists no longer spoke of gravity's failure, but of their own. The problem was not in the equations, it was in the assumptions. The cosmos might not be irrational, only incomplete in the human gaze. The forces that shaped the universe could be layered, overlapping, interwoven in dimensions still unnamed. Gravity, light, magnetism, dark energy, perhaps they were not rivals, but parts of a single unseen harmony, each revealing only a fraction of its face to the observer. And so the rational universe held its ground. No law was broken, no constant abandoned. Yet beneath that calm assertion, a quiet tremor lingered, the awareness that even within the fortress of established science, the unknown still pressed at the gates. For every data point explained, there remained another unmeasured, another question suspended in the black. The story of 3I Atlas was not a revolt against physics, but a reminder of its infinite horizon, that even in the age of precision, the cosmos continues to write in a language humanity has only just begun to learn. As data continued to pour in from observatories around the world, the picture of 3I Atlas grew sharper yet stranger. Its reflectivity varied with no predictable rhythm, suggesting a surface neither uniform nor entirely natural. Some sections gleamed brilliantly under sunlight, while others seemed to swallow illumination altogether, vanishing into matte silence. That duality puzzled researchers. A material both highly reflective and absorptive implied a complex composition, perhaps a hybrid of metallic and carbon-rich layers fused under conditions unknown to the solar system. Spectral analyses hinted at compounds rare, even among interstellar objects, traces of nickel, possibly laced with silicates, altered by radiation exposure over billions of years. To most, it was proof that this was an ancient traveler, older than any world humanity had mapped, shaped by cosmic forces beyond familiar experience. Yet even as the mainstream explanations held steady, the unease among astrophysicists deepened. If Atlas was truly a natural shard, its trajectory should still conform to Newton's cold precision. But it didn't. The anomaly remained, a faint, consistent acceleration that could not be accounted for by sunlight or jets of gas. In late-night conferences and quiet email threads, scientists began to whisper about data that felt too deliberate, too intentional. Its motion did not meander. It aligned as if guided by an invisible geometry etched into the fabric of space itself. But science, at its core, thrives on restraint. The discipline demanded patience, not poetry. And so they returned to numbers, recalibrating instruments, ruling out possibilities one by one until only the improbable remained. The theory of solar radiation pressure, though contested, grew into the most palatable explanation. Calculations showed that if 3I Atlas had the density of an ultralight structure, its apparent defiance of gravity could indeed be a simple dance with light. Photons, those weightless carriers of energy, could nudge its path over vast distances, accumulating into a measurable drift. A cosmic leaf caught in a stellar breeze. This interpretation comforted many. It restored order to the universe. But beneath that order lay an uncomfortable truth. Nature, it seemed, could fashion objects that mimicked design. The distinction between the artificial and the organic blurred. Could evolution itself, stretched across eons and galaxies, produce forms so efficient they resembled purpose-built machines? As this question grew louder, comparisons to Oumuamua resurfaced. Both objects were interstellar, both mysterious, both fleeting. But Atlas was different. It was darker, faster, and its spectral fingerprint bore none of the water or carbon traces typical of comets. Instead, it seemed built from something tougher, more enduring, material that could survive interstellar radiation without disintegrating. Some researchers proposed that these bodies represented a new category of cosmic debris, interstellar relics, fragments from dead planetary systems whose suns had long since burned out. Over time, their surfaces would have been polished by cosmic rays into mirror-like shells, their cores hardened by extreme vacuum exposure. In this light, 3I Atlas became a messenger not of life, but of death, a shard of a forgotten world, carrying the chemistry of extinction across the stars. Philosophers of science saw in this idea something profoundly poetic. Every universe, they mused, might scatter its remains across the galactic sea, leaving fragments as silent testaments to its past. These relics could travel for billions of years before brushing against another civilization's curiosity, igniting new questions about the nature of existence itself. 3. The first Atlas, then, was not an anomaly in motion, it was memory in orbit, a reminder that creation and destruction are inseparable, that the same gravity-binding galaxies can also cast fragments adrift into eternity still. There were others who saw in its motion the faint outline of something more purposeful. If radiation alone could not account for its stability, perhaps another subtle mechanism was at play: electromagnetic resonance, quantum-scale forces, or even the faint drag of the interstellar medium shaping its path in ways not yet understood. A handful of researchers began exploring these ideas, invoking the possibility that objects like Atlas might serve as natural laboratories for new physics. By studying them, humanity could glimpse the edges of reality where gravity, light, and quantum pressure intersect, where the laws of the cosmos begin to bend toward unity. But as the debate expanded, the object itself was already gone, beyond the reach of radio telescopes, beyond the grasp of radar. It drifted into the deep where human instruments could no longer follow. Its data trail ended abruptly, leaving the scientific community with questions instead of conclusions. In that absence, the rational universe seemed both larger and lonelier. For all the precision of its equations, it still withheld meaning. 3. The first atlas had been observed, measured and modeled, yet it remained unclaimed, suspended between the known and the unknowable. In the end, the leading theories did not dispel the mystery. They refined it. They polished its edges into something sharper, quieter, and infinitely more humbling. Because even within the confidence of physics, there lingers the faint recognition that certainty is a fragile construct, that every answer, however elegant, is merely a temporary pause before the next question. And as the last traces of 3I Atlas faded from the solar system, humanity was left with that silence, the silence of a rational universe that still refuses to explain itself fully. No matter how closely it is watched, in the wake of silence left by 3I Atlas's departure, a new era of speculation began, one that blurred the boundaries between empirical science and the uncharted frontier of imagination. The observatories had quieted, their instruments turned toward other targets. But in academic halls and private research labs, the debate had only deepened. For every model that tried to fit ATLAs within the comfort of Newton's and Einstein's laws, another rose that dared to rewrite them entirely. This was the domain of the speculative, the place where science peers over the edge of its own certainties and glimpses, the impossible staring back. Among the more provocative interpretations was the so-called artificial origin hypothesis. It began quietly, whispered through peer networks and late-night symposia, until it surfaced in preprint papers that dared to use words once banished to the realm of science fiction. What if 3I Atlas was not a product of cosmic chance, but of cosmic intention? Its unyielding trajectory, its strange material properties, its silence in the face of solar radiation could be reinterpreted through the lens of design. Perhaps it was a fragment of something far older than the solar system itself, an ancient probe, or a remnant of a civilization whose engineering existed in harmony with gravity, not in defiance of it. The idea was unsettling, not because it was sensational, but because it felt mathematically plausible. A structure only millimeters thick, with mass distributed in ways unknown to human fabrication, could indeed sail effortlessly through gravitational wells, obeying rules written in a language we have yet to learn. If true, then 3I Atlas was not a wanderer, was a messenger. But from where and to whom? The scale of the question dwarfed the human intellect. Even so, some dared to imagine. They envisioned ancient civilizations seeding the galaxy with durable, self-sustaining artifacts designed to outlive their creators. Machines that could survive cosmic radiation, interstellar collisions, and eons of isolation, continuing a mission long after the stars that birthed them had died. Such artifacts would not broadcast signals. They would be the signaler, silent code etched into their existence, waiting to be found by another mind capable of noticing. Then came another idea, more abstract and unsettling, the interdimensional hypothesis. If Atlas defied the gravitational pull of Earth, perhaps it wasn't entirely here to begin with. Some theorists proposed that the object's path only appeared irregular because it occupied multiple layers of space-time simultaneously. To the human eye, bound by 4 dimensions of perception, it seemed to glide unnaturally through the void. But if part of it extended into a neighboring dimension 1, where the curvature of gravity was different, its apparent resistance to attraction might be an illusion of incomplete observation. Quantum field models hinted at such possibilities, describing how fluctuations in vacuum energy could allow for transient overlaps between realities. If 3I Atlas moved partly within one, its motion would look inexplicable within another. Others pushed further, merging cosmology with philosophy. Perhaps this object was not matter at all, but manifestation, a coherent structure born from the quantum fabric of the universe itself, a macroscopic condensation of vacuum energy, stabilized for reasons unknown. In this vision, ATLAS was neither alien nor artificial, but elemental, a rare, spontaneous crystallization of spacetime's hidden architecture. The idea seemed absurd, yet its mathematical beauty intrigued even skeptics. After all, if dark energy truly shapes the universe's expansion, who is to say it cannot, under extraordinary conditions, concentrate rather than disperse? Perhaps Atlas was the universe's own artifact, a mirror, held up to humanity's incomplete understanding of creation. Then came the cosmic sail theory, both elegant and haunting. Some physicists, inspired by light sail technology under development on Earth, proposed that Atlas was a craft propelled by starlight itself, its geometry, nearly weightless and yet immeasurably vast, could allow it to traverse interstellar distances using only radiation pressure. Such a structure would be nearly invisible to radar, glinting only when sunlight struck it at the right angle. The idea ignited the imagination. Perhaps ATLAS was one of countless sails drifting between systems, guided by the faint whispers of stellar photons, a message carried not through radio or mathematics, but through movement. Each trajectory a sentence, each deflection a word. Humanity might have intercepted not an object, but a story written in light. Amid this storm of hypotheses, the boundary between science and mythology began to erode. Ancient civilizations once looked to the heavens and saw gods steering stars. Modern scientists looked again and saw equations guiding Yet now, faced with Atlas, the symmetry between both perspectives became difficult to ignore. What if the laws of physics themselves were not immutable decrees, but expressions of deeper truths still obscured beneath the limits of perception? Some philosophers of science began to whisper that perhaps the universe was not a machine at all, but a conversation. And 3I Atlas, in its defiance of expectation, was a reply. The speculative voices were often dismissed by the mainstream, but their courage had value. They preserved curiosity where certainty failed. For if science's strength lies in evidence, its heartbeat lies in wonder. In the end, every great discovery begins as heresy. Every paradigm, before it shifts, begins as a question whispered into the unknown. In control rooms and observatories, in the hum of data servers and the glow of computer screens, a new kind of patience settles over the scientific world. The patience of those who have glimpsed mystery and refuse to look away. For all their instruments and equations, they know that knowledge moves slowly, that truth sometimes drifts silently across the void, indifferent to the timelines of a single species. And so, the search continues, not with the fever of conquest, but with the humility of witness. Each telescope, each algorithm, each restless mind becomes part of a greater listening, a collective act of awareness stretched across a fragile blue world. The hunt for unseen forces is not merely a pursuit of physics. It is a reflection of humanity's deepest instinct to look into the darkness and wonder what else might be out there, shaping reality in ways we have yet to imagine. Somewhere beyond the heliosphere, the first Atlas fades into interstellar night, silent, solitary, unbent by the gravity it once defied. Yet its absence is not an ending, but a beginning. For in the echo of its passing, humanity has rediscovered the beauty of uncertainty, the realization that the universe still holds secrets vast enough to humble every equation, and mysteries deep enough to keep us looking up, even as 3I Atlas vanishes into the dim frost of interstellar space. Its enigma continues to ripple through the collective intellect of a planet that cannot stop asking questions. Around the world, scientific teams remain locked in silent communion with the stars, re-examining every photon, every trajectory, every shimmer of data that the object left in its wake. What began as an astronomical curiosity has evolved into something far larger: reflection on the fragile limits of perception itself. The failure to fully define Atlas is not a scientific defeat. It is a reminder that comprehension is always partial, that the cosmos perpetually exceeds the grasp of any single generation. The instruments hum ceaselessly. At the Jet Propulsion Laboratory, simulation clusters recreate ATLAS's motion across millions of virtual models. Some demonstrate that subtle radiation pressure could, in theory, mimic the observed acceleration. Others find that the numbers resist harmony. A small subset of physicists begins to whisper about exotic physics interactions with dark matter streams, or even transient distortions in the quantum vacuum, but these ideas remain unanchored to measurable proof. The line between evidence and imagination blurs, and yet, science persists in the tension between them. In a dimly lit control room, analysts overlay data from Gaia's stellar catalogue onto Atlas's escape vector. The trajectory passes near regions where the galactic magnetic field bends sharply, where interstellar gas drifts in complex filaments. Could an unseen electromagnetic current have nudged the object? Could it have carried a residual charge from its origin system? Every answer births another uncertainty. Even in failure, the search refines the tools of discovery, tightening the net that will one day catch truth in its threads. Elsewhere, astrophysicists collaborate with philosophers of science, seeking not technical solutions but interpretive frameworks. They ask whether anomalies like ATLAs reveal the incompleteness of human models or the incompleteness of human imagination. Perhaps what science calls mystery is simply the frontier of cognition, the thin veil separating what can be measured from what can only be intuited. In symposium halls and late-night discussions, this thought takes quiet root. That observation is not passive. It reshapes what it observes. The universe may not merely be studied, it may be, in some subtle way, participatory. NASA's proposed interstellar interceptor gains momentum. Design teams envision it sleeping near Earth's L1 point, its engines cold, awaiting the detection of another interstellar traveler. Unlike previous missions, its path will not be fixed. It will wait, listening, adapting. When the next object is spotted, it will awaken and race outward, chasing the unknown before it vanishes again. The mission is both practical and symbolic, an act of scientific readiness, and an acknowledgement that discovery now depends on anticipation. Meanwhile, AI systems trained on petabytes of sky survey data begin to detect patterns invisible to human reasoning, statistical murmurs of motion that repeat across decades of observation. A few correspond to known comets and asteroids, but some do not. They seem to trace improbable routes through the solar system, faint shadows of visitors that never announce themselves. Were they illusions? Or have we been visited more often than we realized, by objects too faint, too fast, or too strange to recognize? Each flagged anomaly deepens the quiet unease that has settled over astronomy. Perhaps 3I Atlas was not an isolated event, but part of a larger rhythm, a galactic heartbeat too slow for human time to perceive. In conference rooms filled with whiteboards and equations, the conversation grows philosophical. Scientists discuss the possibility that the laws of motion themselves may evolve across cosmic scales, that gravity, like light, might reveal subtle variations when measured across interstellar distances. To question gravity is to question the scaffold of reality itself, and yet the question lingers. If the cosmos is dynamic at its deepest level, then every anomaly is not a contradiction but a clue. Through all of this, the emotional undercurrent remains profound. Humanity, for all its technology, stands as a species newly humbled. The instruments that once seemed omnipotent now feel fragile, like extensions of an ancient curiosity still learning to listen. The failure to fully explain Atlas becomes, paradoxically, a success of wonder, a rediscovery of awe, in an age that too often mistakes certainty for wisdom. And so, the search continues in silence and light. The observatories wait, the data streams flow, the algorithms learn. Above the world, the stars look unchanged, yet behind their quiet glow lies a subtle shift. A civilization aware that something vast and unmeasured moves through the universe, indifferent to comprehension, yet irresistible to curiosity. Somewhere in that infinite distance, beyond the heath, the first Atlas drifts onward, its course unaltered, its meaning unresolved, an emissary of everything still waiting to be understood. In the long silence that followed, the first Atlas's departure, humanity found itself listening not to the static of instruments or the echo of lost data, but to something far older, something woven into the marrow of curiosity itself. For generations, gravity had been the unspoken covenant between matter and meaning, the invisible signature that gave shape to the cosmos and anchored every falling apple, every orbit, every star collapsing into its own weight. It was not merely a force, it was a promise, a quiet assurance that the universe, no matter how vast or cold, played by rules that could be known. But when a single traveler seemed to slip free from that universal hold, even for a moment, the promise trembled. And in that tremor, the human story found its reflection. Scientists called it an anomaly. Philosophers called it revelation. To poets, it was a wound in the fabric of understanding, an aperture through which the infinite peered back. If gravity could falter, even once, what else could bend? What else, once thought immutable, might whisper its exceptions in the dark? The idea rippled across disciplines like a cosmic aftershock. The laws that had guided navigation, prediction, and belief felt suddenly poor as beautiful in their reliability, but incomplete in their reach. For perhaps the truest constant in the universe was not gravity, but mystery itself. Across observatories and lecture halls, the conversations softened from data to wonder. The discovery was no longer about an object, was about the mirror it held up to the species that found it. Humanity had built its identity upon explanation, upon the comfort of knowing that for every effect there existed a cause. But Atlas had arrived as a question with no referent, an equation without closure. Its motion through the solar system left no trail of debris, no tail of vapor or plasma, no signature of intent. It moved with the stillness of inevitability, indifferent to interpretation, yet heavy with meaning. In that indifference, it reminded humanity that not every pattern is meant to resolve. Gravity had always been the symbol of connection, the reason the planets dance, the reason galaxies coalesce, the reason a human body feels the pull of the earth as home. It was the poetry of inevitability, the physics of belonging. And yet, watching Atlas glide through that unseen web untouched, many felt an echo of something intimate, the dream of freedom, to move without being held, to exist without being defined. The parallel was impossible to ignore. Humanity, too, had always sought escape from invisible force, destiny, ignorance, mortality. The object's indifference became a metaphor for liberation, but also a warning. Freedom without gravity is drift. It is motion without meaning. The theologians saw in it a parable of humility. The skeptics saw a test of perception. The dreamers saw a doorway. Each interpretation circled the same silent truth that the universe, vast and unfeeling, still conspires to remind its observers of their smallness. But in that smallness lies an extraordinary gift, the hunger to understand. 3. The first atlas did not break gravity's promise. It renewed it, revealing how fragile certainty must be before discovery can exist at all. As the years passed, its trajectory became a myth carried on the breath of scholars and storytellers alike. In simulation archives, it drifts eternally, frozen in vectors and equations. But in the mind, it continues to move, forever receding, forever beckoning. Somewhere beyond the Oort cloud, beyond the last trace of sunlight, it becomes indistinguishable from the dark that birthed it. Perhaps it joins the silent chorus of interstellar wanderers, ancient fragments of forgotten systems, each one carrying a secret too subtle for human senses to grasp. And so, humanity learns to live with its unanswered question. The pursuit of knowledge no longer feels like conquest, but like communion. To study the universe is to listen, not to command. To seek patterns, not for mastery, but for meaning. The anomaly of Atlas becomes a sacred scar in the language of science, reminder that the unknown is not an enemy to be solved, but a horizon to be approached with reverence. As the final reflections settle, one thought lingers like a whisper through deep space communications, faint but enduring. Perhaps gravity never failed. Perhaps it was mercy letting one traveler pass untouched, so that a world of observers might remember how fragile their certainty truly is. And in that mercy, the universe spoke, not in the rigid syntax of mathematics, but in the timeless language of awe. And yet, even as the light of 3I Atlas faded from the last instruments that could still trace its motion, its echo continued to bend human thought long after its physical form had vanished into the night beyond Neptune's pale horizon. In universities and observatories, the conversations persisted like a low, resonant hum, an intellectual gravity of their own. Some scientists began to speak of it not as an event, but as a threshold. Humanity, they said, had crossed an invisible line from a cosmos of comprehension into a cosmos of questions too large to measure. Every mystery before Atlas had seemed local, quantifiable, destined for eventual decoding. But this one felt different, as if the universe had finally spoken in a dialect designed not for answers, but for humility. In that new silence, the meaning of observation itself began to shift. For centuries, the human species had looked outward to conquer the unknown with clarity. Telescopes became sharper, equations became more elegant, and the universe, once infinite in mystery, appeared increasingly tame beneath the weight of reason. But Atlas resisted that clarity. It seemed to return humanity's gaze with something beyond comprehension, an invitation, perhaps, to abandon certainty and embrace wonder as the highest form of understanding. In its strange defiance of gravity's embrace, it reminded us that knowledge is not a boundary to be reached, but a rhythm to be followed, a cadence between the known and the unknowable. Somewhere deep within the archives of the Vera Rubin Observatory, an image still flickers, a faint smudge against a tapestry of static stars. To the untrained eye, it is nothing, a glitch in a cosmic photograph. But to those who know, it is the last recorded moment before the objects slipped beyond sight. That image has been studied, debated, reframed, and rendered countless times, yet no interpretation captures the essence of what it meant. Because what it meant was not in its light, but in its absence. Its departure left a shadow on human thought, a gravitational void of understanding that no data could fill. And in that void, something remarkable took shape, a new reverence for what might never be solved. The philosophers of physics began to revisit ancient questions. Was gravity truly a force, or simply the geometry of existence folding upon itself? Could an object, moving through dimensions beyond the perceptual cage of human senses, appear to violate those same laws? Was Atlas a messenger from the deep structure of space-time, not a traveler through it, but a revelation of its deeper texture? These were not theories to be proven, but meditations to be lived. They spoke less of mathematics and more of meaning, of the subtle harmony between curiosity and surrender. Artists found inspiration where equations had faltered. Paintings emerged of an object gliding through the darkness like a thought set free from its origin. Poets wrote of a visitor untouched by the pull of home, a cosmic exile that refused to fall. Musicians composed symphonies mimicking its path, long, slow crescendos dissolving into silence. Across the sciences and the arts, the story of ATLAs became a collective myth, not of certainty, but of awe. It became the modern equivalent of a constellation not drawn from stars, but from the shared human longing to see meaning in the void, and in that longing,